In this episode, we're going to talk about artifacts in a way that feels concrete and operational, because artifacts are what your automation is actually moving through the world. An artifact is a packaged output of a build, like an application bundle, a library, or a container image, and it is what gets promoted from build to test to release. A registry is a specialized storage system designed to hold artifacts so teams can publish, retrieve, and track versions reliably. In modern delivery, registries are not just file shelves. They are part of the security boundary, part of the audit trail, and part of the reliability story. If you manage artifacts poorly, you get deployments pulling the wrong thing, builds that cannot be reproduced, and attackers slipping malicious payloads into places that look legitimate. Managing artifacts well means you control who can publish and who can pull, you enforce authentication and authorization rules, and you protect immutability so artifacts do not change after they are released. Once you understand these ideas, you start seeing registries as a core part of operational control rather than a convenience feature. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. The first concept to anchor is why artifact management exists at all. When software is built repeatedly, you need a way to know exactly what was produced, when it was produced, and which deployments used it. Without a registry, artifacts end up in random directories, shared drives, or ad hoc storage locations, and that destroys traceability. It also creates reliability issues because different environments might pull different builds without realizing it, which makes troubleshooting nearly impossible. Registries solve this by giving artifacts a stable identity and location, usually through names and version tags or digests. That stable identity allows automation to say deploy version X with confidence, and it allows rollback to say go back to version Y without guessing. For beginners, the important shift is to see artifacts as controlled objects with lifecycle rules, not as loose files. If you cannot reliably identify the artifact, you cannot reliably manage risk. Authentication is the first gate in that lifecycle, and it answers the question of who is trying to interact with the registry. In operational scenarios, the actors are often machine identities, like build jobs, deployment jobs, or automation services. Authentication is usually done through tokens, keys, or certificates, and the point is to prevent anonymous publishing and anonymous pulling in environments where artifacts are sensitive. A common beginner misconception is that pulling artifacts is always harmless, but many artifacts contain proprietary code or internal configuration, and access to them can reveal how systems work. Authentication also protects the integrity of your supply chain because if anyone can push, then malicious artifacts can be introduced without resistance. In operator thinking, authentication is not just about stopping outsiders. It is also about making every access attributable so auditing is meaningful. When you know who did what, you can investigate incidents and enforce accountability. Authorization is the second gate, and it answers the question of what an authenticated identity is allowed to do. This matters because not everyone who can pull should be able to push, and not every team should be able to publish to every namespace or repository. In a well-managed registry, permissions are split so that build systems can publish to specific locations, deployment systems can pull from approved locations, and humans have limited access based on role and need. This is an operational expression of least privilege, which is especially important because publishing is a high-impact action. If an attacker gains push access, they can replace trusted artifacts with malicious ones, and if an internal mistake pushes a bad artifact, it can spread quickly. Authorization also supports separation of duties, which means the person who approves a release might not be the same identity that publishes it, and the identity that deploys it might not be able to change it. For beginners, the takeaway is that authentication identifies, authorization limits, and you need both. Having one without the other is like knowing someone's name, but not controlling what doors they can open. Registries also play a role in governance because they are natural choke points where policies can be enforced. If artifacts must pass through a registry, the registry can enforce rules like naming conventions, required metadata, or restrictions on who can publish to release channels. Even without diving into tool-specific details, you can understand why this matters. Policies are easiest to enforce at central points that every workflow uses. In operational practice, this reduces the chance that someone bypasses review by publishing an artifact in an untracked location. It also helps with incident response because you can quickly identify what was published and when, and you can restrict access if needed. A registry, therefore, becomes part of your control plane, not merely storage. This is why artifact management is both a delivery topic and a security topic. If you want predictable deployments, you need predictable artifact handling. Now let's talk about immutability, because it is one of the most important ideas for artifact trust. Immutability means that once an artifact is published under a particular identity, it should not change. If version 1.2.3 exists, then version 1.2.3 should always refer to the same bits, not to whatever someone last pushed under that label. If artifacts are mutable, you lose the ability to reproduce builds, and you lose the ability to audit what actually ran in production. You also open the door for subtle attacks where a trusted version tag is overwritten with a malicious payload while keeping the same name. Operators therefore prefer immutable references, like content digests, and they treat tags as pointers that should be controlled tightly. Immutability also reduces operational confusion because it eliminates the question of whether the artifact changed since the last time you pulled it. When the artifact is immutable, a deployment issue is more likely to be an environment or configuration problem than a moving target in the artifact itself. Immutability also influences rollback safety, which is a practical operational concern. If you roll back to a previous artifact, you want confidence that you are returning to the exact same code and dependencies you previously ran successfully. If version tags can be repointed, rollback becomes unreliable because the rollback label might now point to something different than it did during the original success. That turns rollback into another deployment, not a return to a known good state. Operators avoid that by making release artifacts immutable and by controlling promotion mechanisms so that what is approved is what is deployed. This is not about being rigid for its own sake. It is about creating a stable reference that teams can trust during incidents. In stressful situations, you want fewer moving parts, not more. Immutability is one of the simplest ways to reduce uncertainty under pressure. Another important part of artifact management is understanding that registries often serve different types of artifacts, and each type has different risks. Container images can include an entire runtime stack, which means they can carry vulnerabilities and configuration assumptions. Libraries can be dependencies that many applications consume, which means a compromised library artifact can affect many systems at once. Application bundles can include static assets and compiled code that might be difficult to inspect after the fact. In each case, controlling who can publish and ensuring immutability reduces the chance of unnoticed tampering. It also helps with investigation because you can trace which artifact versions were used by which builds and deployments. For beginners, you do not need to master every artifact type, but you should recognize that the registry is a shared dependency, and shared dependencies deserve stricter controls. If one compromised artifact can spread widely, the registry becomes a high-value target. Authentication and authorization also interact with reliability, not just security, because access failures can break pipelines. If a deployment cannot pull the artifact it needs, the release fails, and that failure might look like an application issue when it is actually a permission issue. Operators therefore design permissions to be precise but dependable, and they monitor registry access patterns so they can detect both attacks and accidental breakage. Another reliability concern is consistency across environments. Development, testing, and production should pull artifacts from controlled locations, but the access policies may differ. If access policies are inconsistent, you can have a build that succeeds in one environment and fails in another purely due to authorization differences. That inconsistency creates friction and encourages risky workarounds, like storing artifacts in unapproved places. A good registry strategy makes the approved path the easy path, while still controlling who can publish and who can promote. That balance is part of operational maturity. A subtle but important operator concept is the difference between publishing and promoting. Publishing is creating a new artifact and placing it into a registry location. Promoting is moving an existing artifact through stages of trust, such as from a testing repository to a release repository, without rebuilding it. This matters because rebuilding introduces variation, while promotion preserves the exact artifact that was tested. Immutability supports this because the promoted artifact remains the same bits, only its trust status changes. Authorization supports this because the identities allowed to promote should be limited, and promotion should often be subject to approvals. This is a supply chain safety concept. Even if we avoid implementation detail, you want to know that the thing you deployed is the exact thing you tested. When you can enforce that, troubleshooting becomes easier because you remove uncertainty about whether the artifact changed. Beginners can remember this as build once, test that build, deploy that build, which relies on registries and immutability. Another common risk is artifact confusion, where different artifacts share similar names or where tags like latest are used casually. If a pipeline pulls a tag that moves, you can get unexpected changes without any code change in your repository, which is a nightmare for debugging. Operators avoid this by using explicit versioning and by preferring immutable references where possible. They also enforce naming conventions so that artifacts are clearly associated with projects and environments. This reduces the chance that a deployment accidentally pulls from the wrong repository or uses a development build in production. Even without specifying exact naming rules, the principle is straightforward. Ambiguity is risk, and clarity is control. Registries are designed to reduce ambiguity, but only if you use them with discipline. When you see teams arguing about what version is running, that is a sign artifact identity and immutability are not being handled well. To close, artifact management is where delivery and security meet in a very practical way. Registries provide a centralized system to store, identify, and retrieve artifacts so builds and deployments are repeatable and traceable. Authentication ensures every interaction is tied to a known identity, and authorization ensures identities can do only what they are supposed to do, especially when it comes to publishing and promotion. Immutability ensures that once an artifact is published, it does not change, which protects trust, auditability, and rollback safety. When these pieces work together, you reduce supply chain risk and you improve operational reliability because deployments are pulling known, stable artifacts from controlled sources. The operator mindset is to treat artifacts like controlled inventory with chain of custody, not like random files you hope are correct. When you can explain why that matters and how controls reduce blast radius, you are thinking in the way modern automation expects. That is the foundation for building pipelines that move fast without losing control.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.